Hello, folks. Today we're going to be talking about mass airflow sensors. So we talked about MAP sensors and BMAP sensors last week. Now we're going to get into mass airflow sensors. So they're a little bit different. If you remember what I talked about in lab, and also I talked in the previous, there are two ways that the computer can computer calculates the amount of fuel and the timing, and of course there's other things that contribute to this, but we start in a map sensor system. We use the speed density system, where we take the speed of the engine and how much volume of pressure or absence of pressure we have in the intake, and we use that to calculate how much fuel and what timing. Depending on what the load value is, what speed it is, that's how we calculate it. The other way is through a mass airflow sensor system. That's what we're going to be talking about this time. So we'll be talking about how it works and the different types that are out there, and you kind of talk about the PCM, how the PCM uses the mass airflow sensor, and the methods to test it, and that's what we're going to be doing in the lab this week. And this also, it's going to kind of prep you for this level of the engine performance part of it, or in another class. Also, it'll prep you for the advanced levels and stuff like that, and also get you ready for your ASE A8 type of testing. Not everything, but it'll give you some starting. So, of course, the purpose is, like I said before, is to figure out how much air is coming in. There are some weaknesses to the mass airflow, which I kind of discussed a little bit before, but basically, depending on how much ducting, or where the air has to go from the mass airflow sensor to the intake manifold, a lot of the companies are bolting the mass airflow right up to the intake manifold now, which is the way the old school was. They had it over here by the air box, and then they had a big old air ducting going around, and anything in that path, if it had a hole in it, it gave false information to the computer, and the computer thought there wasn't as much airflow going through. It did an improper calculation and caused a problem. But we have a hot film type system, which we're going to be talking about, and we're going to talk about a hot wire one also. And this is one. It's a one type of sensor. This is the hot film type one, and this one actually has a little piece. Well, it actually a hot wire that comes through, and the idea is on this one is if we put air through, we have a sensors inside, and when you push air through and it goes past that wire or that hot film, it causes it to cool down a bit. So we'll run a certain amount of amperage to keep that film or that wire as hot as it was before. So we're going to look at the values between the incoming and the past the film, and see if we can keep it regulated at the same temperature. If we can, then that means pretty much there's nothing going on. But if we get air going through, and the amount of cooling and the amount of amperage we have to get it back up to temperature, that is what we calculate as airflow. So we take that amperage difference, and the computer takes that value, and it calculates as the amount of airflow going in. So here's an example right here. This is a hot wire type thing, and the other thing about the hot wires too, they have a heater to them. Well, it is a heater, but after the vehicle is shut down, a lot of times what they'll do is they'll let that wire burn any kind of debris that might be attracted to it or on it, to keep it nice and as clean as possible. So what are the most common types of mass airflow sensors? Of course, is the hot wire and the hot film. It's the most popular one, to put it that way. There are other, there's a vortex type sensor that actually uses ultrasound waves to actually go across. Not as popular, but it's out there. I just want you to be aware of it, and make sure that you know there are other types out there. Now, Chrysler actually was using this. I don't think they're using it. I think they went back to the hot film and the hot wires and stuff. But this is actually one right here, and it actually, it kind of looks at this, the sound waves and how it's actually changed along the way as it go, and then it calculates as airflow. So depending on what kind of amplitude and well, more so the frequency is what we're actually looking for. So the PSM uses the airflow sensor, actually to do the calculations. Like I said before, it needs to know how much air volume so we can actually, increase or decrease the amount of fuel that it needs. It's going to open up these injector. I should say it's going to turn on the injector longer or shorter periods of time. It's going to use this, and also it helps in backup to the actual TPS. If it sees amount of airflow and the TPS isn't moving, then it's going, wait a minute, TPS is, we got a problem here. Or vice versa. If it doesn't see airflow and you see the TPS moving around, we're kind of saying there's a problem here, Houston, we need to diagnose it. So that's when it starts flipping on the lights, and you might have reduction of speed and performance at the same time too. So how do we test the mass airflow? Well, one, you, of course, like we always do first, any of the sensors, we look for a visual inspection. We want to look at it. We want to look at the wiring with the connectors. We did find out one sensor in the engine performance class that actually had a connector. Somebody had been probing in there and bent the actual wires inside there. So we tried to do the best we could to get it back into shape, but it really needs another connector. We can do the output test, and depending on the brand and all, we're going to be measuring frequency, and it usually gets converted into grams per second, or grams or pounds per minute. It depends on the manufacturer. And then we can actually do a tap test on it. And this is a light tap. This is not get there and start smacking on it. I've seen some guys do that before, and of course they're going to fail. But you'll see a change in your readings. And that's a good example too. And then of course the digital meter test of the actual mass airflow. The digital meters. So these are going to be your frequency driven ones. So what is false air? I kind of described that a little bit, and this next picture really has a good example of this. And like I said before, it depends on, most of your manufacturers are now bolting the actual sensor right up to the intake manifold now. We used to have ducting going across, almost looked like a dryer's ducting. And I've seen some guys do that, and it's hilarious. But this could have a crack in it, and that causes false air. So now this the mass airflow doesn't see that, and that's what can cause miscalculations from the computer. So what are the 4 ways to test the mass airflow? We talked about it: visual inspection, the mass air output test, the tap test, and the digital meter test. So what can cause the sensor to give false readings or fail? Of course, dirt, oil, silicone, some of these silicone sprays, to clean things up with. Some of the, if you get an engine that's using a lot of oil, and it can actually cause oil to come through the PCB system that goes down into and cause problems. If it's been sitting for a long time, well, I've seen this too, vermin get in there and they make little nests out of it, like your spiders, and the good, the mice and rats and all kinds of, things can happen. You know, if that wire gets insulated by any of the debris above, it can cause it to not do the correct. One of the things I found too is mice like to eat plastic, and same with rats, and they'll take the insulation off, and then you'll have a problem there too. So if you have holes, you have all these things, it can cause it to give incorrect. Also, contamination can cause problems too. So a digital oscilloscope, or DSO, is a great way to measure and test a mass airflow sensor. Don't forget, you can also use your scan tool, looking at grams or pounds per minute or second. And that's another one. And then again, you've got to come down to specifications, how much should be coming in at a certain speed and all like that too. And this is kind of showing you how the digital oscilloscope can be used to monitor the operation of the mass airflow. Connect the test leads to the signal wire. And remember, some will have 5 and 7 wires on the mass airflow, just depending what's inside of it. Some of your mass airflows will actually have a air temperature sensor built into them too. So keep that in mind also. And you want to look for consistent patterns. So this is a good example right here. So it's a nice consistent pattern. Now this is measured in hertz, and it will change as the speed, just like we've seen on some of our permanent magnet sensors. You'll see as you accelerate, it'll kind of come in and go out. You'll get more movement going on. Also, you'll have more more peaks and rises as you go to. What are some of the can be the results of contamination? Of course, incorrect air volume entering, and it underestimates it. So hopefully this helped a little bit. This is a quick little overview of the actual mass airflow sensor. So we'll be talking more about it as we go along, and I will be talking to you soon. Take care now. Bye for now. I'm going to go ahead and stop this right now. Take care. Bye.